class name, chapter 9, force and laws of motion. So first we go for Newton's first law of motion. The first part, it has two parts. The first part of the statement says that a object at rest will remain at rest unless it is acted upon by a net force. Once again I will repeat, a object at rest will remain at rest unless it is acted upon by a net force. The net force is nothing but the unbalanced force. So for example, see here, consider a surface. An object is placed on that. The mass of the object be 10 kg. It will be at rest unless if we act and force towards the right or towards the left or towards east or towards west. See here, if we are not applying any force on that object, the object is at rest. Still, there are forces acting on that object. The forces are the weight of the object due to gravity, that is W equal to mg. Mass of the object is 10, acceleration due to gravity is 9.8, so 98 Newton of force is acted by that object on the surface. So this surface again will give an upward force which is called as normal force, that will be equal to 98 Newton. This weight due to gravitation and the upward force, normal force, are called balanced forces. They are equal in magnitude and opposite in direction. That makes the object to be at rest. Suppose if you are applying a force towards the right, this force makes the object to move. This force is called net force or unbalanced force. This force is called net force or unbalanced force. This is the first part of what? Newton's first law. It says that an object at rest will remain at rest unless it is acted upon by a net force. Net force is nothing but unbalanced force. Here the normal force and the weight force are balanced force. I think you can understand this. We will go to the second part of Newton's first law of motion. Newton's second part says that an object in motion can continue in motion unless acted upon by a net force. An object in motion can continue in motion unless acted upon by a net force. This part of the statement gives a technical term in physics, that is inertia. So Newton's first law of motion is also termed as law of inertia. So see here, I will explain this by an example. Try to understand that. Suppose I consider one rough surface. An object is here. This object is moving with a velocity v. It will move to some distance and it will stop because the rough surface, a frictional force will be acting opposite to the direction of motion. So a frictional force, if the object moves towards the right, that is east, the frictional force will move towards left. It makes the object to come to rest. Here no other external net force is acting, but what happens here? The objects come to rest. Suppose if you are considering a smooth surface, for a very fine smooth surface with less friction, you consider the ice surface. Here when you make the ball to move with the velocity, it will move for a long distance. It will reach a long distance and finally it will come to rest. Here friction is more. Here friction is less. That too the object will come to rest. Why? Because if the object is moving in the ground surface, the air molecules will move in opposite direction and will make the object to come to rest. So these are some of the typical cases which cannot apply Newton's first law second part. So when we throw an object or an object is given an initial velocity, the object to be continued in motion, we have to take the outer space. In outer space there will be very less friction. So what happens? Now we will come for another example to explain Newton's first law of motion. From this I will give you 3 mathematical formation. Keep it in mind and keep it for solving problems. So in our solar system, consider the sun and Earth is revolving around the sun. So here the Earth is revolving around the Earth, has to move like this in this direction, but the attractive force of the sun is in this direction. Both are perpendicular, so the Earth will take a circular path and it will move in the circular path around the sun. So from the previous examples and illustrations, I give that if the object is at rest, we can say that net force is equal to 0. Suppose the object is in motion. In motion also constant velocity. There is no change in velocity. Then also this net force will become 0. Why? Because acceleration will become 0. We know that acceleration is equal to v minus u by t. Here the velocity is constant, so initial velocity and final velocity are same. So the acceleration is 0. So net force will be 0. If net force exists, then acceleration will exist. If acceleration is 0, net force is 0. These are the two conditions. At rest, net force will be 0. In motion also, if the object moves with constant velocity, net force will be 0, because acceleration will become 0. We know that acceleration is equal to v minus u by t. So we will get as 0. From now now Newton's second law of motion. Newton's second law of motion gives that F net is equal to product of mass into acceleration. This net force can be written as summation of F is equal to m into a. Here, from this statement, we can write if m increases, net force will also increase, because they are directly proportional. Suppose we are keeping the mass constant, acceleration of the object increases, then net force will increase. Clear? F net is equal to product of mass into acceleration. F net can be written as summation of F is equal to m into a. If m increases, F net will also increase. Suppose m is constant and the acceleration increases, F net will also increase. So the logic behind here is, if mass increases, acceleration will decrease. If mass decreases, acceleration will increase, which implies that F net will be always constant. Clear? I think you can understand this. We'll go for next part. We know that F net is equal to product of mass into acceleration. But we know that acceleration is equal to change in velocity by change in time. So we can write product of delta V by delta T. Here it comes a new term called momentum. Momentum is equal to product of mass into velocity. Momentum cannot be realized in daily life. I will give one example that from that you can conclude what is momentum. In physically, it can be said as it is the product of mass and velocity. Consider a car moving with the velocity 30 miles per second. Consider a train moving with the same speed 30 kilometer per or 30 miles per second. Both are having same speed, but the momentum will be different. Since the momentum of the train is high, it is not easy to stop the train easily. Since the momentum of the car is less, it can be stopped easily. This is the comparison between what? Momentum. This is the explanation for momentum, that is product of mass into velocity. Now I will interchange this. F net dot delta t is equal to m into delta v. Here product of mass and velocity, that is change in velocity, so we can write as change in momentum. Delta represents change in momentum. Here the product of net force and time gives a term called impulsive force. So from Newton's second law, we can conclude that impulsive force on an object is equal to change in momentum. Delta P, that is equal to change in momentum. Newton's third law of motion. For every action force, there is an equal and opposite reaction force. The statement is, for every action force there is a equal and opposite reaction force. So first of all we will understand with some examples. So consider a smooth surface, that is icebergs or ice surface. A person is with the skating and he is having a ball. If he want to go to left, that is west, he has to throw the ball to the right. So right side direction. So he is giving a force of 100 Newton to that ball. The ball will move towards east and the person will move towards west with the same force, that is 100 Newton. Suppose if you are considering the graph, see here the ball is in right x-axis and the person is towards negative x-axis. So this force will take the value of minus 100 Newton. This will take the value of plus 100 Newton. See here, the magnitude is same, but direction is opposite to each other. That is, action force and reaction force have same magnitude, but they are acting in opposite direction. Second example, consider a boat. A person is in the boat. He is having a ball on the hand. If the boat has to move towards the west, he has to throw the ball towards east. Here we have to consider one thing, that The mass of the ball will be small, but mass of the boat and person will be large. So what happens? The ball will move to a longer distance, but opposite direction, this boat and the person move towards the west with a little distance because of mass. If mass is less, acceleration will be more force. If mass is high, acceleration will be less, but the net force will be same. The force will be same. I will explain this with a problem. See here, I will write the problem first. Ravi pushes Raja. Ravi's weight is mass is 60 kg. Raja is 90 kg. With the force of 540 Newton. Question A. What force does Raja exerted on Ravi? Second question, what acceleration does each person experience? What acceleration does each person experience? See here, Ravi 60 kg mass pushes Raja 90 kg mass with a force of 540 Newton. What force does Raja exert on Ravi? What acceleration does each person experience? So see here, solution. Suppose this is Ravi exerting a force of 540 Newton on Raja. He is 60 kg. Here it is 90 kg. So first find the acceleration of Ravi. A is equal to F net by M, that is equal to 540 by 60, that is 9 meter per second square. For Raja, its A is equal to 540 divided by 90. It is 6 meter per second square. So if mass is less, acceleration is high. See here, mass is less, acceleration is high. Mass is high, acceleration is less. but the force is same. So whenever we apply, the action and reaction forces are always equal in magnitude, but it will act in opposite direction. Here Raja exerts a force, Ravi exerts a force towards east, so it can be taken as plus, and Raja exerts a force towards left, so it will be taken as minus. To check vector, that is direction, this is minus represents towards west, plus represents towards east. I think you might have understood about the basics of Newton's first law of motion, second law of motion, and the third law of motion. And if you have any doubts, you can ask in WhatsApp or in group by writing a statement where you feel difficult. We will meet in the next class. Bye.